This is the Unit 4 video tutorial for pages 1 and 2. Alright, so the big thing that we learned today was the difference between chemical properties, physical properties, and then chemical changes and physical changes. So if you were absent especially, make sure you're reading these notes. Push pause and read them on your own. Okay. A physical property is something you can observe without destroying the object. So you can look at the color of something without changing it. You can look at its shape. You can measure its mass on a scale or measure it with a ruler. You can smell it. You can measure temperature with a thermometer. Okay, it doesn't change what it is. All right. So if I was, for example, talking about this paper is pink. That is a physical property. I can do that without changing it. Okay. Chemical properties then, reacting is the key word for chemical property, and the original substance is fundamentally changed. It's different. So if I want to decide this color, that's physical. I can do that without changing it. If I want to decide how flammable this is, I would need to light it on fire, which changes it into smoke and ash. So flammability would be a chemical property. Okay, so taking a look. Blue color, it says, is a physical property. Density is mass divided by volume. I can calculate that without changing the sample of gold, or without changing the paper, or without changing anything else. So density would be physical. Flammability, again, I would need to burn it, and burning it would change it. So that's a chemical property. Dissolving, we learned about this in class, also in lab. Dissolving something can be undone. If I dissolve sugar into water, I could evaporate the water off or boil the water off, and that would leave me the sugar behind again. So dissolving is always a physical change or a physical property. Reacting is always chemical. Supporting combustion means, will it burn with oxygen? Well, in order to tell if this highlighter will burn, I would have to light it on fire, which would change it. So that would be chemical. Physical property, to tell if it breaks, okay, which is basically like this paper. How easily does it break? How easily does it tear? Okay. Did I change it? Well, some people would say, yeah, you ripped it, but it's still paper. I didn't change it. Changing the shape would still just be physical. Okay, it's still paper, as opposed to burning the paper, flammability. That is changing the paper. Okay, so we come down through these. That's how we're doing it. Is it physical? Am I changing it? Seeing how shiny it is. I don't have to change it. Seeing what temperature it boils at. This is a good one, number 12. When I boil water, it boils at 100 degrees Celsius. Someone says, yeah, but it's not water anymore. Now it's steam. But it's still H2O. Okay, water, liquid, is H2O. Boiling it, it's still H2O, which means I really didn't change it. I just changed the state. Coming down here, we're looking at the difference between intensive and extensive physical. Okay, again, that's the difference between intensive and extensive physical properties. Intensive properties stay the same. It doesn't matter how much you have. Properties are going to stay the same. Extensive properties changes with the amount. Instead of saying present, I would say that exists. Okay, extensive, EX, is all about how much exists. So if we're looking at M&Ms, okay, intensive properties would be the same no matter how many I have. Extensive properties would change depending on how much exists in my sample. I have like 70 in this cup. I have 6 in this cup. So what has changed? What hasn't changed? The mass of these two. Look at how many there are, right? They don't weigh the same. This one weighs much more, okay? So I would say mass is an extensive property. Make sure you're stating why. Because more of a sample existing is going to weigh more. Volume. Do these take up the same amount of space? No, it changes. So extensive, this would be extensive. It changes. More of something takes up more space than less of something does. Color. Are they all assorted colors? Yeah, no problem. So color would be intensive. They have the same rainbow of colors. Conducts electricity. They're chocolate. Chocolate does not conduct electricity. A lot of chocolate does not conduct electricity. A little chocolate does not conduct electricity. So this is a property that stays the same even with more. That would be intensity. Intensive, excuse me. Shiny, smooth, density, length. try to consider how much chocolate do you have, or do you have a lot of chocolate, a little chocolate? Do you have a lot of golds, a little golds? Intensive things would stay the same. It doesn't matter how much exists. Extensives change with how much exists. Go ahead and turn over to page 2. Page 2, instead of talking about physical and chemical properties or talking about physical and chemical changes, they're very, very similar. Okay? So please go ahead and write this down. In a physical change, the original substance still exists. Okay? So I told my students to write this. Physical changes, you can undo them. Okay? So if I melt a popsicle, I could freeze a popsicle and undo it. That's a physical change. If I evaporate water, I could condense it down again. That's a physical change. If I dissolve something, I could evaporate it and undo it. So physical changes can be undone. So really two big types of physical changes. The first would be any state change, which means solid, liquid, gas, melting, boiling, freezing, condensing, sublimating, and and deposition or deposing. That's from our notes today. The second big thing is shape changes. If you're just changing the shape of something, putting hair gel in, you're just changing the shape. You can undo that by washing your hair. Ripping something, cutting something, breaking something, bending something. Okay, you can unbend it. It's still gold even if you bend it. That's a physical change. Chemical changes make something new. A new substance is produced for a chemical change. So really, reaction is the key word for chemical. You're reacting, or you can't undo it. Cannot undo. Okay, you can't unburn something, but you can unmelt something. Okay, dissolving. I can undissolve something. We did this in class. If I evaporate off the water, the sugar will be left. That's undissolving it. Okay, hydrochloric acid reacting. I have this reacting with this to make something new, a new substance. Reacting is always chemical. Cutting. When you're cutting something, you are changing the shape. It's still sodium. It's just two pieces of sodium. It's still pink paper. It's just two pieces of pink paper. So I didn't chemically change it. I only physically changed it. Water boiled and changed to steam. So here it's liquid H2O. Here it's vapor or gas H2O. But it's just a state changes. Liquid to gas. So that's physical. Decomposing in a chemical reaction. Chemical. Iron rusting. You can't unrust something. You can clean it off, but you can't turn that iron oxide back into iron. So you cannot undo it, which means it is chemical. All right. I had a lot of people asking me about 10 and 12 in class, and then also 17, 18. So let's look at that. Milk souring. If you got milk that you leave in your fridge when you go on vacation, you come back, and it's 3 weeks expired, it's going to be chunky and smelly and gross. You can't unrot that milk, right? So once milk has gone rotten, you can't undo it, which means it is a chemical change. Dissolving, number 11, is always physical because you can undo it. Number 12, wood rotting. If you cut wood, cutting is physical, but rotting wood, you can't unrot something. It is decomposing. It's changing into something else, right? Number 17 and 18. That's kind of gross. But when food is digested in the stomach, it is turning into something not so fun to talk about. It is changing its chemical compound. You can't undigest something. That is a chemical change. And water being absorbed by a paper towel. It's still paper towel and water. If you wring out that paper towel, you can get all the water out. So you can undo it, which means it is physical. All right, so always ask yourself, can I do the opposite of it? If you can, it's physical. If you can't, it's chemical. These questions down here, 19 through 24, are all exam type questions. These are straight from the notes, number 19 and 20. So be really careful. You should have this memorized from the notes. Matter is defined as anything that has mass and takes up space, which basically means anything that has mass and volume. Things that are not matter would be energy. My students in class did a really good job of saying light and sound. Really, any of the electromagnetic waves from Unit 3, radio waves, microwaves, infrared light, visible light, ultraviolet light, gamma rays, X-rays, those types of things. All of them are not considered matter. Everyone in my class, when I said, what's an example that's not matter? Every single class, the first thing that people said was air. Air is matter, guys. It's made of things like oxygen and carbon dioxide, and there's lots of nitrogen in the air, okay? Those all have mass. They're on the periodic table. The mass of oxygen, the average atomic mass is 15.999 AMU. It has mass. Air is mass, guys. Careful. All right, other things that would be matter. Protons are matter. Okay? Any atom has mass. It takes up space. I am made of matter. The table is made of matter. Your homework is made of matter. Those things that are matter. These are the things that are not matter. The difference between solid, liquid, gas, plasma. We're not talking about plasma this year. Not in chemistry. You might get there in physics. So really, our only choices here are A, B, and C. Solid, liquid, or gas. So if a gold bar, which is very, very valuable, has a definite volume and definite shape, that means neither can change. Solids have a shape that doesn't change and a volume that doesn't change. If this sample of nitrogen has a volume and shape that both change to match the container. So if neither can change in 21, they're solids. If both can change, then it must be gas. If shape and volume do not change, solid. If it has a set volume, but it can change shape, that would be liquid. Okay. We did this in our notes. If you are absent, please make sure you're coming in to get the hard copy of notes so you can copy. All right, my next video tutorial, I will do pages 3, 4, and 5.